Hello, Assalamualaikum and good day. So I'm Faiza. Today I'm going to teach how to get the lateral earth pressure behind the wall. Okay, for this exercise, look at this question. So determine Rankine's active force PA per unit length of the wall and the location of the resultant for the returning wall shown below. Okay, the clue that we have here is the Rankine active force. So if Rankine active force, meaning that for Rankine the wall is smooth, so no consideration on friction. So no friction between the wall and soil here. So it's assumed there's no friction between the wall and soil. It's for Rankine's theory. So Rankine's theory, wall is smooth. This wall is smooth. Okay, and then the question asks for active force. So active force, you have to calculate Ka. Okay, for the first layer lucent, phi is equal to 30 degrees. So Ka, okay, so 1. So Ka is equal to 1 minus sine phi over 1 plus sine phi, which is equals to 1 minus 30 sine 30 over 1 plus sine 30. So it's equal to 0.3333. Okay, so for Ka2, for layer 2, this is layer 1, this is layer 2. Okay, so Ka2 is equals to same equation, 1 minus sine phi over 1 plus sine phi, which is phi is 36 degree. So 1 minus sine 36 over 1 plus sine 36. So the answer is 0.26. Okay, now Ka1 is 0.333 and Ka2 is 0.26, which is lesser than Ka1. So normally when phi is higher, okay, phi is high. If the phi value is higher, so Ka will be lower. Okay, for this case, phi is lower, phi 1 is lower than phi 2. Phi 1 is 30, phi 2 is 36. Phi 1 is lower than phi 2. So Ka1 will be larger than Ka2. Okay, so Ka1 equals to 0.333. So Ka2 equals to 0.26. Okay, so Ka1 is larger than Ka2. Okay, now I'm going to show you how to sketch the lateral earth pressure diagram behind the wall. Okay, just now we know that Ka1 equals to 0.3333 and Ka2 equals to 0.26. So we know that Ka1 is larger than Ka2. Okay, now normally I'm going to divide the sketches, the pressure diagram, based on first, if we have the charge, So this is the charge. Q equals to 20 kilonewton per meter squared. That is a surcharge. So I'm going to sketch for surcharge. Okay, surcharge is always in rectangular. Okay, so and the surcharge is constant from the top to the bottom. Okay, this surcharge 20 kilonewton per meter squared is constant from the top, from the ground level to the bottom. Okay, but because of the Ka value is different, so the diagram would be a little bit different between the top layer and the bottom layer. So what will happen? Okay, because the diagram is rectangular, because of the Ka1, because this is Ka1Q. So because of Ka1 is larger than Ka2, so this is Ka2Q. This is Ka1Q. Okay, and here is Ka2Q. Okay, next we're going to sketch is on the soil. Okay, the soil is always in triangle shape. Okay, why triangle shape? Because it depends on the vertical stress, and the vertical stress is going to increase from the top to the bottom. As we go down deeper, the vertical stress will increase because vertical stress is equals to gamma H. Okay, so as the H is increasing, going downward, going deeper, so the H value will increase. So when the H value increase, so sigma V is also increase. This is remain, unit weight of the soil is remain. Okay, so for soil layer 1, so sigma, this is actually sigma H, which is equals to Ka1 sigma V. And where is sigma, and what is the sigma V for the layer 1? Sigma V for layer 1 is equals to unit weight of the loose sand, which is 15, times with the height of the loose sand, which is 3 meter. So it's a 45 kilonewton per meter square. Okay, then this layer 1 is considered as a charge to the soil under layer 1. Okay, beneath. So this layer, the loose sand, will be considered surcharge for dense sand. So we have to draw something like this, a rectangular. Why rectangular? Because this is act as a surcharge, but not from this surcharge, but surcharge. This surcharge is overburden pressure. This soil, the whole take all this soil, loose sand, will be overburden pressure, will give an overburden pressure to the soil underneath, which is dense sand. So this will be Ka2. Why Ka2? Because this rectangular is for soil layer 2. So Ka2, okay, but sigma V1, okay, sigma V1. So sigma V1, okay, same value sigma V1 for this triangle. Okay, so for this triangle we have sigma V, right? Sigma V. So this sigma V is the same as what you have to use here for this rectangular. Okay, next we look at the same lateral earth pressure from the soil layer 2 itself. So another triangular, okay, another triangular. So this will be Ka2 and sigma V2. Okay, so how to get that sigma V2? Sigma V2 is equals to, because this is a saturated soil, the soil is submerged under the groundwater level. So for the effective unit weight, it will be 19 minus 10 is the unit weight of the water, okay, times with the height, so 3 meter, so equals to 9 times 3, which is 9 times 3, 27 kilonewton per meter square. Okay, so this is sigma H. So this is sigma H2. Okay, so this is also sigma, consider sigma H for that for this rectangular. This rectangular, at the bottom is the sigma H. Same goes to here. This is sigma H for this rectangular. Sorry, right, not rectangular, triangular. Okay, so then the next one is about water table. Okay, so water also contribute to the lateral earth pressure. So this is for water, because water doesn't have K value, because sigma H and sigma V of the water is always equal. Okay, same. So here this is sigma V for the water, okay, which is equals to the height, the unit weight of the water, which is 10 times with the height 3, which is equals to 30. Okay, 30 kilonewton per meter square. Okay, so that is how to sketch and to calculate sigma H, which is horizontal stress. Okay, and then you label all the diagrams. So this is number 1, number 2, number 3, number 4, number 5, and number 6. Now you can start calculate your PA. So are you going to have PA1, PA2, PA3, PA4, PA5, and PA6, or P water, okay, from the water. Okay. Right, and then each PA, it depends on the where you're going to take a moment. Okay, so normally we take a moment at the toe of the wall. Okay, at the toe of the wall. So moment is always moment is always force times with the distance, and the distance is always perpendicular to the force reaction. Okay, so now let's look how you get the H for each PA. If your take a moment is at the toe, which is somewhere here at the toe of the wall. Okay, so the H1 would be half of this rectangular, half of this rectangular plus with this height. Okay, plus with this height. Okay, now we're going to determine the H for each PA. Okay, so the first one, so H1 for this PA, this rectangular, okay, PA1 is a half, sorry, which is equals to H1 is equals to half of 3 plus 3. Okay, remember the wall is 6 meter height. The wall is 6 meter height. This is the groundwater level, so this is 3 meter, and this is also 3 meter. So H1 is for height for PA1, from PA1 force to the bottom of the wall. Okay, so H1 is half of the rectangular, which is 3 meter height, and then you have to plus with another 3 meter. Okay, so that is 4.5 meter. Okay, so 3 divided by 2 and then plus 3, so 4.5 meter. And then H2, so H2 is height for this PA2, so this is the height for H2. So this is H2. So H2 is half of the height of the rectangular with 3 meter height, so it is 1.5 meter. Okay, then H3. So H3 is the height of this PA3. This PA3 is this triangular. Okay, this triangular number 3. Okay, so H3 is equals to 1/3. Okay, 1/3 times the height plus 3 meter. Okay, 1/3. Okay, because we take 1/3 from this this triangular. Okay, the height is 1/3 from this triangular plus this another height. Okay, so 1/3 of the 3 meter plus another 3 meter, so this is equals to 4 meter. Okay, 4 meter. And then H4, so H4 is this one, height for PA4 for this rectangular number 4. Okay, so H4 is half of the height, 3 meter, which is equals to 1.5 meter. Okay, then H5. So H5 is height for this PA5. So this PA5 is for this triangular number 5. This triangular number 5. So H5 is 1/3 of 3 meter. 1/3 of the 3 meter, which is equals to 1/3. Sorry, 1/3. 1/3 of the 3 meter, so it's equal to 1 meter. Okay, and lastly is H6. So H6 is the height for this PA, this triangular number 6 from the water. Okay, so 1/3 from 3 meter height, which is equals to 1 meter. Okay, that is how to calculate the height for each PA. Okay. I'm going to show you how to calculate each PA. So the first PA is this rectangular number 1. It's from Sir Judge. Okay, so PA is how to calculate PA. PA is based on the area of the shape of the diagram. Okay, area. So the first shape of the diagram is rectangular. So PA1 is based on the area of the rectangular, which is the base. The base is KA1 Q times with the height. Okay, the height is 3. Okay, so KA1 is 0.333 times with Q 20, and then times with 3. So PA1 is 20 kilonewton per meter. Okay, for the second rectangular, so we're going to calculate PA2. So calculate the area of this rectangular number 2. Right, so PA2 equals to the base. Base is the KA2Q times with the height. So equals to 0.26 times 20 times 3 equals to 15.6 kilonewton per meter. Okay, so now PA number 3. So PA number 3 is a triangular shape. Okay, so triangular shape. So how to get the area of the triangular shape is half of the base times the width height. Okay, so PA3 equals to half of the base. The base here is a sigma h, which is KA1 sigma V1. Okay, which is equal to half KA1 0.333 times weight, unit weight 1 is 15 times with the H1. So H1 is 3. So you will get 22.5 kilonewton per meter. Okay, so PA. Okay, now let's see PA4. So PA4 is rectangular shape. So how to get the PA4 based on the rectangular shape area. So PA4 is equals to base. The base is KA2 sigma V1 times width height. So So equals to 0.333 times with unit weight 1, which is 15, times with h1, which is 3, and times with another height 3. So that will be 35.1 kilonewton per meter. Okay, so that is PA4. So now PA5. So PA5. So PA5 is triangular. So PA5 triangular, which is half of the base. Base, what is the base? Base is Ka2 times with sigma V. Sigma V is gamma 2 times with H2 and then times with H2. So it is equal to half times 0.26 times. This is effective. Unit weight is the effective. So 19 minus 10 times with H2 squared. Okay, H2 is 3, so 3 squared, so that will be equal to 10.53 kilonewton per meter. Okay, and then lastly is PA6. So PA6 is also triangular. So the area of the triangular is half of the base. Base is unit weight of water times with height of the water, and then times height, so height of the water, so equals to half times 10 times 3 power 2, so which is equals to 45 kilonewton per meter. Okay, so done with the PA. And now the total PA, the total lateral thrust is equals to PA1 plus PA2 plus PA3 plus PA4 plus PA5 and plus PA6. Okay, so this PA6, either you want to use PA6 or you can define as P water. Okay, so 1 2 1 2 3 4 5 6 1 2 3 4 5 6, and now you have 6 P. Okay, 6 lateral force, you have 6 height. So to get the moment, okay, so now to get the moment, okay, so moment taking at the toe here is equals to PA1 H1 plus PA2 H2 plus PA3 H3 plus PA4 H4 plus PA5 H5 plus P water H water, or P6 times with H6. Okay, so finally the moment is 311.58 kilonewton meter per meter. Okay, so we know that P, total PA, is equals to 148.73 kilonewton per meter. So finally we will know where the lateral thrust act, either at this height, or somewhere below here. So to know that line of action for our PA, the lateral earth thrust, so The H where the lateral earth thrust act will be equals to summation of the moment divided by summation of the PE. So we will get H is equals to 2.1 meter. Okay, that's all. I hope you understand my explanation. Try do it by yourself. Try to do other exercise given. Right, thank you. Bye.